Alright guys, welcome to the lesson on half-life. You should have a handout that looks something like this. Your teacher may have copied it for you 2 pages or 2 pages to 1, or it may just be copied single. And then on the back we've got a few practice problems for you. So let's go ahead and get started. Again, this is the lesson on half-life, and this is Collins Hill High School. We're at 50 Taylor Road, Swanee, Georgia, and my name is Trey King. I teach chemistry here all day. So let's get started. Up here at the top, the half-life notes. It says, nuclear reactions occur because the nuclei are trying to become more stable. An uneven number of protons, remember those have a positive charge, and neutrons have a neutral charge or no charge, cause an unstable nucleus. Alright, moving on to the second point, any element larger than the atomic number 82, and if you'll check your periodic table, many of you have a pink sheet, the periodic table, look for lead right down here. All elements larger than the atomic number 82, which would be lead, go through some type of nuclear decay. There are many smaller isotopes like carbon-14. Okay, if you remember carbon has an atomic number of 6. Okay, its most common isotope was 12. If you remember rounding the atomic mass to get the mass number of 12. But this one we're talking about carbon-14, one of the isotopes, not as common as carbon-12, that go through nuclear decay as well. Carbon-14 is used for dating organic materials, okay, like fossils and such. The half-life of carbon-14 is 5,730 years. Using this number, they can get an estimate of how long an organism lived or some type of other carbon-containing material has been around. Uranium-238 is another common isotope that radioactively decays. The energy released from the decay of uranium-238 is trapped and used as energy in nuclear power plants. Uranium-238 has a half-life of 4.46 billion years, so it's quite a contrast there. Polonium-214 has a half-life of only 163.7 microseconds. If you look down at the bottom of the page, I'm going to scroll up, and this is just a table of half-lives for several of the more common isotopes. Okay. Now remember, an isotope, okay, is a version of the element on the periodic table that has a different number of neutrons in the nucleus. It has to have the same number of protons or it won't be the same element. So this is a list of several of the radioisotopes, meaning that they're radioactive. If you look at polonium-214 that we just mentioned, okay, 163.7 microseconds. Okay, we go all the way out here to uranium-238. Okay, it's 4.46 times 10 to the 9th years, which would be billions of years. Okay. All right. The point being is that we're just trying to make the point that not all radioisotopes have the same half-life length. The rate of decay of a radioisotope is measured in half-lives. Okay, that's what we measured in as half-lives. That's where we get the name half-life from. One half-life is the time that it takes for 1/2 of the atoms in a sample to radioactively decay. Okay, so that makes sense. Okay, a half-life is the amount of time that it takes for half of the original atoms in a sample to radioactively decay. So here's an example of how we would actually calculate this. Okay, this method, we just refer to it as the box method. If you can kind of see what's going on with it, here's a perfect example. A half-life example number 1, an element has a half-life of 4 years. This means that it will take 4 years, okay, that's important information, for half of the sample of this element to decay. If you start with 100 grams, okay, of this element, how much will you have after 12 years? Second part of the question, how many half-lives is this? Okay, a couple things to note. You're going to be given how long a half-life is. You're going to be given how much you originally started with. Okay? And you're going to be given how long you're going to observe it for. Alright? So you'll be given 3 things in order to figure this out. And this is just the box method, we call it. for lack of a better name, of how to get this set up. So let's take a look and let's go ahead and get started. I'm going to roll this up, and if you'll just follow along with me right here. All right. So in this first box, if you'll notice right here at the bottom, it says put the amount of the original sample. If you go back and look at the problem, it says if you start with, okay, so that's obviously the original amount. So we're going to put 100 here. Okay, make sure you put the unit. That's going to be grams. Then at the arrow, we're going to put the time for 1 half-life. Okay, go back and reread your problem. You'll see that an element, this particular element, has a half-life of 4 years. So we're going to put 4 years here. The next step is half of the amount from the previous box. Well, the previous box would be this one to the left that has 100 grams. So we all know that half of 100 is going to be 50. Put your unit, 50 grams. Okay. Then when we go to the next half-life, we're going to keep up with the total amount of time that we've watched it for. Remember, this was 4 years. This was 1 half-life. 4 years, we had 100 grams radioactively decay to 50 grams. If I add 4 more years to this, okay, I go from 4 to 8 total years. Okay, this obviously is 2 half-lives. Okay, so now 8 years has gone by, so 50 now becomes what? Of course, 25. Then we go to 25 grams. Okay. If you follow this, if you get lost, take a look. Time for 2 half-lives is equal to 2 times 1 half-life. 1 half-life was 4, so 2 times 4 is 8. Then we get to the next half-life. Okay. Time for 3 half-lives. 3 times 1 half-life. So 1 half-life was 4. 2 half-lives was 8. So this time 3 half-lives is going to be, that's right, 12. Okay, so this is 3 half-lives, and I just put that down there just to help me keep track of it. So now we know half of 25 is going to be, 12.5. All right. Now this is, okay, remember 25, half of 25 is going to be 12.5. So this element has gone under radioactive decay for 3 half-lives. How long did that take? That took 12 years. Okay, so we're going to take a look. How much will we have left after 12 years? Well, it's going to be the answer in this box, and let's just write it right here. 12.5 grams. Okay. How many half-lives is this? 1, 2, 3. Just count your arrows. Okay, and that's going to be 3 half-lives. Pretty simple, huh? All right, let's take a look at the next part of the page. Okay. One second, sorry about that. Okay, here we go. So here are the steps that we go through. If it's not really obvious what to do, you can always go back and take a look at this, okay? Step number 1 is put the original amount of sample in the first box. Step number 2 is put the years for 1 half-life over the first arrow. Step 3, divide whatever the original amount was in half and put that number in the second box. Okay, the second box to the right. Multiply years of 1 half-life by 2 and put above the second arrow. And then finally repeat steps 3 and 4 until you get to the desired number of half-lives or years that's given to you in the problem. Okay? And then just a couple little quick reminders. To get the number of half-lives, just count the arrows. Okay? To get how long a half-life was, take the total number of years and divide it by the number of half-lives. This tells you how long it took to get the remaining mass. And we'll do this one right here just together before we turn you loose to work on those on the back. Alright, we're going to do the same method that we did before. Remember, we call this the box method. Alright, so here's the given information. We're going to start off with a 60-gram sample. Okay, of a radioactive element will be left for 4 days. Okay, that's how long we're going to watch it. It has a half-life of 2 days. Alright, so go back, take a look at the problem. What's going to go in the first box? the original sample amount, 60 grams. What's going to go at this arrow? Well, it's going to be the half-life. Okay, we're going to watch it. We're going to have a half-life for this element for 2 days, which is 1 half-life. Half of 60, of course, is 30. Okay, I'm going to watch it for an additional half-life, so now it's going to be 2 times whatever this was, so this is 4 days. Okay. And this is the second half-life, and then, of course, half of 30 is going to be 15. All right, and that's all we're doing. Just follow it every time. So how many half-lives was this? 2. All right. How much of the original sample did we have left after 4 days? We had 15 grams. Okay. Just in case they turn the question around on you, they're may ask you how much has decayed after 2 half-lives for 4 days. Well, if this is what I have left, and this is what I started with, just find the difference. Just subtract the 2. So this is the amount that remains. Just make a little note just in case they flip it around on you. Okay. The amount that decayed would be 60 grams minus 15 grams that I have left. And you know the answer is going to be 45 grams. Okay. This is the amount that had decayed. Because the question could be asked either way. Okay. This question is looking for this answer, but they could very well ask how much has decayed as well. Alright, for your practice problems, just go ahead and set all of them up the same way. I'll go ahead and start this first one with you, and then we're going to turn you loose and let you finish the rest of them. Alright, please give them all a try. This is really not going to be that difficult. A whole lot easier than what we've been going over. Okay, this is the original sample amount. How much is left after 15 days? I know the half-life is going to be 5 days. Okay, so the question always comes up. How many boxes do I need to draw? Well, let's just figure it out on our own, okay? So let's start it off right here. 1 box. Here's an arrow. Okay. Put the original amount in here. Put how long the half-life is. This is going to be a 5-day half-life, or 5 days. That's 1. Okay. We're going to watch it for how long? This is how long we're going to watch it, for 15 days. Okay. So draw another box. Half of 120 is 60. Okay. Get ready for your next arrow. 2 times 5 means that 10 days has gone by. That would be 2 half-lives. Half of 60 is going to be 30. 30 grams. Go to the next half-life. I haven't gotten to 15 days yet, but I guess you can tell where we're going. 3 times 5 is going to be 15 days, and that's what the problem's asking us. Okay, that would be 3 half-lives, and then half of 30 is going to be 15 grams. Okay, and that's what they're asking us for. Okay, how much will be left after 15 days? They could easily ask us how many half-lives that is, and that would be 1, 2, 3. So how many boxes do I draw? You draw as many boxes as it takes to get to the answer that you're looking for. Alright, so go ahead and start this one on your own. Okay, we start off with a 60-gram sample. How much is going to be left after 8 days? And then here's your half-life of 4 days. I appreciate you watching. Go ahead and finish up the rest of this page, and we'll see you tomorrow. Have a great evening.